I'm Dave Fano. That's me. I'm gonna I am sort of appropriating big data. And when people talk about big data, it's massive amounts of information. So it's sort of big data ideas or concepts or potentials for the building industry. And I'm going to show some of the stuff that our app development group has been doing that start to touch on these topics again. Not, it's very much big data light, but really it's more to provoke and instigate and get some ideas going. I try to keep these things fairly loose and conversational, so please ask questions at any time. So just to get a sense of the room, there's a couple assumptions in this presentation. I have like Facebook stats, and I never envisioned I'd be presenting it at Facebook. So when I made this presentation, so, how many of you guys are from like the actual tech world, not building at all? Okay, that's mostly building folks. Makes me feel a little better. And any coders, like actual programmers in here? Okay. Okay, cool. So everyone's mostly building industry people. Oh, I can say anything now. All right, cool. Well, with that, we'll get going. I'm Dave Fano. I'm one of the founding partners at a company called Case. We call ourselves Building Information Consultants. Myself and the two guys that started the company were trained as architects. We worked for an architecture firm in New York City called Shop Architects. It's a pretty geeky architecture firm. At least they were when we were there. Now they do big developer projects and make a lot of money. But when we were there, we just kind of broke software and did stuff. And we started this company about 5 or 6 years ago to be able to keep doing that stuff. And so we work with architecture firms, engineering firms, and what we're trying to really position ourselves as is building information specialists. It's beyond Revit or CATIA or Rhino, Grasshopper, or whatever it is next week. It's really about looking at that data and information in those models and how it ultimately makes its way into the design, construction, and operation of facilities, because we think that's how we can make the biggest impact kind of on the built environment as a small little consulting group, is if we really kind of help the industry use data better. So we kind of have distilled this down to building information is good business. Now we're about 30 so odd people. A third of our company is a software development group. It's a big part of our business, and something we're really excited about, and it's kind of fun. It's where we still flex our design muscles, since we don't really take on design work proper. And I head that group up as well as heading up the company. So I know enough to be dangerous. I can answer a lot of the technical questions, but I probably couldn't tell you about particular classes that were written to make some of these things. So talking a little bit about how I think people are using information in the kind of broader world outside of AEC. Some just overall stats. These come from a book that's probably targeted towards like executives of big companies and a bunch of big data kind of buzzwords, but some are actually still pretty interesting. And Google processes 24 petabytes of data per day. That's, I can't even quantify what a petabyte is. It's just a ton. In physical terms, it's thousands of times the quantity of all the printed material in the U.S. Library of Congress. A day. Facebook, being here, gets 10 million new photos uploaded every hour. This is the amount of information that we just produce on our cell phones. Each one of these photos is geotagged, it's got your face recognized, all that kind of stuff. Parallels to what we do with buildings, and it's pretty pathetic. But we'll keep going. Twitter, last year, exceeded 400 million tweets per day. So again, the amount of information that we're producing is pretty remarkable. And you might be thinking, or you might not be thinking, this is social media. What's it have to do with buildings? That's, if I were to be talking in an architecture firm, they'd be thinking, oh, that's for my marketing department. We've got a Twitter, and we do tweets to show when we do new projects, and that's about it. But it's, I think there's a lot of embedded potential in there, because architecture, the role of architecture is to create space for people to do things, how people use space, how people engage in space, what people do in space. So if there's this social media out there that's all about people, information about people, as an industry, we should be using it. So Foursquare, which I think is probably fairly passé at this point in social media terms, but one would think it's just this check-in thing, especially if I were to be talking to architects. Oftentimes I ask how many people, actually I'll ask in here, how many of you use Foursquare? How many of you have ever used Foursquare? Okay, how many of you don't know what Foursquare is? Oh, okay, that was not expected, but, so all right, Foursquare, tutorial on Foursquare. Foursquare is a sort of seemingly silly app where you check in to where you go. You go to places and you tell your friends, I'm here. And oftentimes the response is, why the hell would I do that? The reason I use it is to bookmark physical places, like a good restaurant I went to, I don't want to remember that I went there. And then there's like an incentive program, there's game mechanics, there's some really smart things that they've done. But like things on the internet, people use it. And they have a lot of really interesting information. So what this is 1 day of check-ins in New York City. And what you're seeing now is essentially a usage analytics at the urban scale. So one would think that master planners, urban designers, Foursquare would be a goldmine for them. Like before you go ahead and put a mall, let's see how this city's being used. What stores are people checking in at? And this is happening daily and all over the world. Actually, if you go to their Vimeo channel, you can see Tokyo, you can see San Francisco. Some pretty amazing things. Some of it you can kind of intuit, but some of it you can't. Oh, they also have a really amazing one during Sandy. You can see how part of Manhattan is just like black, no one's there. But you can see the different times of the day, the different things that are happening in Manhattan, where people are living in Brooklyn, people that are coming from the outer boroughs, the activities, the colors represent different activity types. So when the city goes into nightlife mode versus work mode, and at lunchtime when people, the different places that they go to eat. So if you're an architect and you're being asked to, say, design a restaurant in a certain neighborhood, let's go to Foursquare and let's see, how far will people travel to go eat? And start to take more of a quantitative or empirical approach to design. So anyways, that kind of the point here is this seemingly dumb stuff that everyone says, oh, Twitter, why would I tell people what I'm eating or when I need to go to the bathroom or whatever, is actually a goldmine for really, really interesting information for architecture and the built environment, not just for Disney or ABC to know what TV shows people want to watch. Who in here is familiar with the quantified self kind of movement? A few of you. Okay, so that one's gotten a bit more traction, I'd say, mostly because people our age are buying these things for our parents because we want them to be healthy. I bought one for my dad because he's fat, and I want him to, but he lost his Fitbit, so that didn't really go anywhere. But it's this movement towards quantifying everything. If you kind of set measures or goals, you need to kind of be able to track how you're doing. And so if you don't measure, you can't track. And the quantified self is all about that. It's all about whether it's wearing a wristband or one of these things, and if you're like me, you've lost 3 of them at this point, or a scale that tells you what your weight is, things like that, and tracks it for you, and then give you things like this. This is my dashboard from 6 months ago, because like I said, I lost my Fitbit. But it's going to tell me how many steps I've taken a day, how well I'm sleeping, sort of estimates on my calories that I burned a day, all that kind of stuff. And people like my dad are doing this. But the more of the provocation here is, why aren't buildings doing this? Why aren't we measuring buildings, cities, real estate portfolios in a similar way? why aren't we aggregating Fitbit data and thinking about the happiness of a building or of a company? Those things actually do affect productivity and things like that. And this is a way to talk about design that is not happening now. If you do this, this will be the impacts on your workforce. Sounds pretty kind of dull, but if you really want to have an impact, these are the ways that we could do it. It's not just kind of intuitive recommendations. And the data's there. Oftentimes, people say, oh, the data's not there. We, as architects, we couldn't do that if we wanted to. There's no way to measure that. And I just think that's not true. I think it's just kind of a lazy answer. There's ways to get that information, whether it be, there's a lighting control system in this room right now. And if the lights turn off, it'll probably, Facebook could probably, being the innovative company that they are, measure when the lights are on and off in a room and how often it's being used, if a conference room is being booked, if the ones that are little are used a lot, or if the ones that are big are not. And they'll probably use that before they go and build a new space because they're just an analytically driven company. And there's nothing that says architects can't do that. I would think that there's a service contract after a building's finished that you deck it out with sensors and you go and you check it. And that's part of an ongoing maintenance contract with a building. But as an industry, we've been more concerned with originating buildings than kind of tending to buildings or seeing how they operate. And that's really how we could have an impact. Just making new ones with great glass or environmentally friendly materials is only going to go so far. If the building's not run or operated in the right way, then that's all kind of irrelevant. So, yeah, I think building information is going to be the way in which we can actually have that impact. So I'd say all that stuff is what's generally being defined as big data. Big data is one of those terms that's being reappropriated by a lot of different people and defined in tons of different ways. It kind of starts to border on like religious arguments. And so I'm not going to try to do that. I'm just going to use it as a term for just using information for making decisions. And so, yeah, big data, you'll see it on the cover of a lot of magazines now. All the kind of CEOs of big companies are talking about this kind of stuff. And so I think it's not necessarily hardware. You'll go to a talk about big data, you'll hear about things like Hadoop or big hard drive that they need to use. Sure, it's kind of those things, but again, I really think about it more as using information for decision making, and that could be business intelligence or data mining. They all, for me, all kind of blend together, but I would say, kind of in a broad brush kind of way, that the AECO, architects, engineers, contractors, and owners, for the non-geeky acronym people like me in the room, don't really use it. I'd say, and GIS, there's some stuff happening in the other room with GIS that's pretty interesting, but I'd say GIS might be one of the closest at the urban design level.
Can you explain what GIS?
Geographic information systems.
Geographic information system.
Yeah, so it's used a lot by kind of municipalities, cities, government organizations, and urban planners, urban designers.
Census.
The census. All that's mapped in GIS. One of the big providers is a company called ArcGIS. The parent, actually that's the software, the parent company is Esri. They've been in that space for years. So for me to define it, you guys are free to define it however you like. It's a mindset and approach. It applies to all companies, us as a small 30-person organization. The way we look at our financials, the way we look at our resource planning, I'd say those are kind of approaches to using data for making business decisions. And I think it's an enormous opportunity for the AE professionals as a whole. So I think it's about, obviously, the data being the unprocessed, raw stuff. The metrics and the analysis that you do or pull from that data might be real time. The way we think about data, kind of static Excel files, that's snapshots. You're aggregating large amounts of data or collecting. So one of the principles of it is you just take everything rather than a small subset of very organized and clean data. You take massive amounts of data and you just don't care how clean it is. It's It's what you're gonna discover stuff in it. And it's to ultimately take you to a place where you're driving performance, making decisions, and gaining insight on whatever it might be, a building, a business, practice. Any questions so far? Nope? All right. This is a kind of, I don't know if it would be a computer science diagram, or it comes from a lot of information management. And it's just an adage that first you have data, which is the kind of raw, unprocessed thing. That becomes information, which is some sort of organization on top of that data. Once it's organized, you can use it to kind of create knowledge or transfer knowledge. And then once it's knowledge and used, it can be recontextualized, and that's what it's wisdom at that point, where you have that level of comfort with the information. And so I would suggest that same thing applies to buildings. We've got building data, that raw stuff, what we have, whether it be in the design side of things, something like Revit, ArchiCAD, AutoCAD, Rhino, whatever, those things all produce raw design data. Actually, I'd say they go straight to information because it's pretty structured. But if we look at the built environment, then we've got sensors, BMS systems, that's building management systems, spatial information management systems, SIMs, and all that data, again, like this room, we can probably get the lighting controls data, or all sorts of different stuff, key card data for a whole building. Take that, mine it, and then learn about a facility, and then make new decisions as you make new facilities. So for me, the opportunity is leveraging that building data to deliver building wisdom. And I would think all AE professionals, everyone involved in the process of creating facilities or running facilities, should be leveraging this information to make decisions about the way facilities are run and constructed. Everyone familiar with BIM? Anyone not familiar with BIM? Any no's in here? All right, so BIM, Building Information Modeling. And I do a lot of training and all those kinds of things around BIM. There's a lot of reluctance. And for me, I'd say that architects and engineers for the longest time have been working with building information. They're building information experts, whether it was via schedule, a specification, even drawings. A drawing is an instruction set to how a building goes together. So for me, that is all building information. Architects, engineers, contractors, especially contractors, are very, very good at managing building information. But when that M got thrown on there, everyone kind of freaked out, and that they had to work with models, and that the industry was changing, and it was fine the way it was. But really, it's just a tool to manage building information. And for me, that's super exciting. I would think everyone would be pretty jazzed about it, but some are not. So with that, that's kind of my pontifications on big data for the AE industry. What I was going to do now is just show some examples of some of the work we've been doing that touch on these concepts, not to the level that we want them to be, but we're kind of working our way there. So this is a project we worked on with NEAD Architects. It used to be Polshek, for anyone that follows New York firms. This was an existing campus. It's NYU's medical campus on the east side of New York City. So about 2.5 million square feet. And some of the buildings are from the late 1800s, and some are as new as a couple years ago. And they were brought on to do a 30-year master plan for this campus. And the first thing they had to do before they proposed anything was assess what they actually had, because they didn't really know. They had two sets of information. They had what their facilities group had, which is like as-built drawings, paper drawings, maybe some CAD, and then what their capital planning group had, which was all Excel spreadsheets. And after we did I'm not going to say it's like to the inch calculation of what they had, but we took all their as-built drawings and recreated them as a BIM model, a low-resolution BIM model. And there was a discrepancy of about 10% between those two groups. And they were about to build a cogen plant to produce their own power. And they were planning it for 10% more square foot than what they had, which resulted in tens of millions of dollars more in construction. just by not knowing what they had. So a simple little exercise, gave a landowner that kind of insight into their portfolio. And then from there, they were able to use this in the kind of typical modeling ways for parametric modeling. But what we were doing here was analyzing the various design options, whether it was a different configuration or different building, different program types, and getting that information straight back out of models so design decisions could be made. Energy analysis, this is something that's been done for a while. We were brought on by Autodesk to help them build up a little interface for comparing various energy models. So oftentimes the analysis will get done, and then it's that analysis. You're not comparing the different situations. Revit in particular has an integration with Green Building Studio. If I'm saying names of software or things that are not familiar to you guys, just tell me. I tend to forget that people aren't as nerdy as me and aren't playing with these things day in and day out. So Revit has this functionality, and technically what it does is it dumps a little XML file to your hard drive. And so they wanted to be able to compare those various analyses that were done on individual projects. So if you change the glass type, what does that mean? Or if you change the materials, what does that mean? So we built a little charting graphing library that sits right inside of Revit and allows you to check all the different analyses that you've run and then look at them and compare them. So not necessarily big data, but if you scale this out, do it to an existing facility, different buildings on a particular campus, and those are, again, potentials of the kinds of things that could be happening. Get a time check. Any questions so far? All right. Data for design analysis. How many of you in here use Rhino and Grasshopper? A few of you. So Rhino's a modeling platform, a really good modeling platform. Josh was showing it earlier. And then Grasshopper is a plugin that sits on top of it for kind of visual scripting and visual programming. And it's pretty profoundly changed the industry. And so here we're working with Snøhetta. They're designing SF MoMA. That's a really good design firm. This is with their Oslo office, not their New York office. And they had this design of a corporate office that they were doing in Oslo. And they very much liked the concept, but didn't want to just be composing the orientation of these louvers. They wanted that to have a direct impact on the way the building performed and the way people experienced the building, or even the way they worked there. And then there was also the requirement that they had to prove out to the city certain performance criteria. So there was a Grasshopper definition built to control each of the surfaces and the orientation of those louvers, and then when you change them, that would run an analysis on the room. And then that was hooked up to an optimization algorithm or component, not to make it sound fancier than it is, that comes out of the box with Grasshopper to tell this is the optimal orientation. If you don't like it, you can change it, and these are the impacts of changing it. But they could do that by setting up the model this way. And it's just using the tools you have, using information to make design decisions.
Is that with Ladybug? Which one is
Diva.
Diva?
Yeah. Ladybug, well, you ask Mustafa, he's here, he wrote it. So here's some more work that we've been doing recently with understanding how data can go from software to software. We don't really want to be bound by the proprietary nature of one software or the other. And the basic concept is that we can distill building elements down to just data. Right? A wall is points, lines, and then properties. Floors are the same thing. They all have, it's all physics and geometry, so we should be able to do that. And as long as software has some programmatic way to interact with it, then we can recreate geometry. We don't have to do things kind of the dumb way. So this was a little R&D project we did with Big's architecture firms doing some pretty amazing stuff these days. I'm sure most of you have heard of them, but in case you haven't. And they had been modeling a lot of this stuff by hand, and they were required by the client in this case to use Revit for documentation. But Revit sucks for iterative design modeling, but it's really, really good for documentation. And we are kind of firm believers in using the right tool for the job. So one of the guys that works with us, one of our associate partners who's exponentially smarter than I am, his name's Nate Miller. That doesn't mean that much, but he's really, really smart. Has been working for a while on building out these tools that will break down grasshopper definitions or the geometry in a Rhino model to points, lines, kind of the bare components, and post them to wherever, either a binary file that sits in your computer to a web service. That's kind of the least relevant part. And then, I feel like I've been trying to talk slow to get this video to finish. There we go. Then on the Revit side, there's a series of tools that kind of ingest that information. And what we've got now is a data-driven link between two applications. So something like the building levels could then be imported and recreated. If you're not a Revit user, some of this stuff may not seem as valuable as it is, because doing this stuff by hand really sucks. So all these floors you're seeing here are actually, it's as if Revit had drawn them. They are schedulable, if that means something to you, selectable, you can compute the volume, all that kind of stuff. And then you can go back to something like Rhino and Grasshopper. That's a very good iterative design tool, a very robust parametric interface, and you can push that data back out, and then Revit can re-ingest that data. Let's see if I can fast forward here. So the idea is, Nate got a little overzealous when he made this video. He was very proud of this definition. But you republish that data, and then Revit can reload it. And this is, what's more interesting to me here is the concept of passing information between applications. This particular one is whatever, but even from like Revit to Revit, something like building levels, building grids. If you're a Revit user, you know what copy monitoring is and all that stuff, which always breaks, makes your models really heavy, but really all those are just data points. It's an elevation, that's it. That could be an Excel file. And so to say that there's this Excel file that's the rule set, the structural engineer uses it, mechanical engineer uses it, the owner uses it, and that becomes the reference point. And what you're doing then is taking buildings and essentially converting them into databases and letting people pull the data that they want, rather than giving them the entire thing and say, okay, now you have to dig through it and find what you want. And that's the kind of overarching concept for this. And we've been building out different modules, whether it connects to Rhino, Grasshopper, Inventor for fabrication, because you've got different levels of resolution for geometry depending on which phase in the process you are. And if we can just break it down to its component parts, then having each software do what it does well becomes a narrative that makes sense.
Dave?
Yes?
Case was pulled in to build that application?
Yeah.
That allowed for the transfer, right? I mean, the translation into Revit?
In this case, no. We took it upon ourselves to just make them. Okay. And now we have them as sort of tools in our tool chest, and we more get brought in to help just pass the data back and forth. Okay.
So, but that was a deliverable you were able to give to Dig that they could use on future projects, I'm assuming?
Sort of.
Okay.
But yeah, not to get too into it, but in this particular case, we our approach with these tools that we've made is that the important part is the end product, the building, and so we don't want to be a software company.
Okay.
And by saying that there's some sort of software that helps manage this is really kind of trivializing the problem, because the passing the information part is really the easiest part. It's how you define that definition, how you create your componentry in Revit, what you want to be iterating on, and there's a kind of strategic component to that. That's really what we're bringing. So that's why we don't really sell the tools. If you bring us on to help you figure that out, We want to do the problem solving. That's the part that's fun for us. And we just kind of throw the tools in. That's been our general approach to that kind of stuff. Here's an example of a project we've been working on for a few years now. And it's the underlining concept of this one kind of fast forwards in different spots. So the data that lives in something like Revit can be used in that particular Revit model at that particular moment in time. Projects are usually made up of multiple models, lots of models. There's things in there that you can't necessarily get access to. So the idea was to take the data from all the models in the whole practice and aggregate them and then see what you could find in there and take sort of a data mining approach to BIM. So we built a little model indexer, grabs everything in there, even things that you don't see through the interface. That gets, technically what's happening for any coders in the room is we're taking the whole model and we're converting it into XML files. Then those XML files are transferred over to a web server. That web server processes those XMLs and ingests them into a database. And then that happens in an automated way weekly. The kind of bigger concept is Google Analytics for BIM models, so that you could start to be looking at these things and doing kind of data-driven QA/QC. Because with BIM, you don't necessarily know what's in the model, and clients are asking you to deliver the model. Drawing set, you can flip through it, red line, you caught that. But in the model, there's hundreds of thousands of rows of data and parameters and fields, and it's kind of impossible. So in a firm like SOM, where they're having to do lots and lots and lots of projects with lots and lots and lots of models with lots of different people at different levels of experience, this becomes a pretty daunting task. So all that data is processed and presented back in a web dashboard. So you could look at the whole company. Yeah, sure.
When you're saying that, the Revit model, all those various models got to be in different formats. How are you bringing them over and commonalizing them, if you will? Because they're all native. Are you exporting them to something prior to bringing it into XML?
Yeah, we've got a schema that we've defined. So like every category in Revit, all the parameters right out, yeah.
So for each interface that they were used to develop the various models, you first convert it.
Yeah, we wrote a Revit tool that extracts Revit models, but it's only Revit.
Okay, that's what I was getting at. So it's only Revit, it's not whatever other software they might be using. Okay.
Yeah, it's only Revit.
Thank you.
Okay, cool, thanks. So then that all gets processed and presented back in an interface like this. And so here you're looking at a project that's made up of 20 models, and you can start to do some high-level kind of analysis on these projects. Which one has the most families in it? Which one has the most links in it? Things that if a BIM manager had to open all 20 of those models, it would take them a week. We took on one of their projects their kind of model auditing process from 40 hours to an hour because they were able to look at this stuff. Other things like, we're not quite there yet, but say a project manager who wants to look at what's in a model without having to open Revit, they could do that by logging in here. We're also timestamping all the pushes, which is something that is difficult to do. So how has a model changed over time? Does it have more families now than it did last week? Does it have more groups or links? All that kind of stuff, when it's all in a database, becomes a little easier to do than when it's in a kind of native Revit file. And then data-driven standards checking. Taking something like a firm template and comparing it to any project model and seeing which parameters have been changed. Again, making sure that the information that's in these models is something that should be, and if it shouldn't, how do you revise that? I'd say this one's probably one of the closest to, not even big data, but the database for this is now, I think, close to 40 gigabytes of just pure data. We're not extracting geometry. We're not dealing with that at all. Just pure information. So this year we're looking at what we're going to do because the database is getting too big. Towards the end on the operations side, at the end of the process, taking all of the elements that are in a BIM model and then handing that over as a database to a facilities owner, so that they can then track when that equipment was last serviced, if there's sensors in the building, what's going on with that stuff. Putting QR codes on elements, something like this projector, when the last time the bulb was changed, all that stuff is building data, costs money if you don't do it. So building out a simple interface. We did a Navisworks and kind of database integration. Really some similar concepts to what I showed on the last project, but for the operations side. This is one that it's not that sexy looking, but 'cause it's one of the kind of earlier projects we did, but it's a really interesting area for us that we're doing more and more research in, is data for construction, lean production planning or production monitoring. There's quite a bit of research happening in the Lean Construction Institute, different construction firms on tracking, that's what I think is called, put something in place. Tyler could tell me.
Work in place tracking.
Work in place, so
Production control.
if you know that the expectation, I'm going to really generalize this to something pretty simple, but you are going to install 1,000 square feet of drywall, and a subcontractor makes a commitment to 2 people a day, and they can each put in 100 square feet of drywall, that means after 10 days I should be done. And if I ask them to track every day how many square feet of drywall they put in, and they've only put in 400 by the 5th day, I know they're not going to meet the deadline because they're off. So this was a whole interface for tracking commitments. This is all a process called pull planning, which comes from Kanban, which is all, again, lean project management. But you get a bunch of people to collaborate and make commitments to staff counts, what activity they're going to do, by when, where they're going to do it. And then you have to track when it happens. This video is super slow. But then we created a whole interface around that. And the idea is that subcontractors would log in, track what they did, and then you can go back, look at the pull planning sessions. These are, this is taking a physical process and digitizing it. They put a bunch of sticky notes on the wall and track all that stuff. I call this data for fabrication. It's really more around modeling and saying that geometry is fabrication. But Josh showed much cooler stuff about this than we would, so I'm just going to skip that one because I'm running out of 5 minutes. Data for business analysis. This is a screenshot straight out of Tableau, but we're also oftentimes looking at different data visualization technologies. Tableau is one that comes from the financial world that takes different data sources and visualizes them in different ways, and I think is probably one of the most compelling software for the AEC market, other than the BIM stuff, where it's a nice companion to that stuff.
What did you call it?
It's called Tableau.
Oh, Tableau.
Yeah. This is a little prototype. This is just a front end. It's not connected to anything. But looking at some potential applications of real-time analytics. So having an add-in that sits inside of Revit. And like I said, all this data is not real. This is just a prototype of a front end, because you'll see the names are like Jimi Hendrix and things like that. So just so you don't think I'm trying to pull a fast one on you. But the idea would be, we've already built some prototypes to test it, but have an add-in that sits inside of a software like Revit, and then tracks who's in the model, who's synchronizing with Central, who's working in it today, what kind of major activities are happening, is something like a level deleted, kind of important elements, and so that you could track it and log in and see, kind of get quick stats on individual models. So new ways to get insights into collaborative models. This one is processing HTML files, so something that's kind of just a dumb data source that comes out of Revit, which is these error warning files, and looking at ways to just use something like regular expressions to take a seemingly useless HTML file and do something pretty valuable with it. So for anyone that doesn't know, Revit produces these warning files. So it tells you this thing's broken, attached to these 200 elements, and it just comes in this big mess of an HTML file that's pretty useless. So we just processed it and parsed it and made a simple little web interface into doing that. Again, fairly trivial stuff. It's just looking at ways to leverage the information. So this is tracking particular types of warnings across a file. This is one we're going to be launching soon. This is just a front-end mock-up, but we're going to try to take a sort of big data approach to hardware benchmarking specifically for BIM applications. So we're going to be releasing a simple little add-in that'll pull your hardware specs and then run a bunch of tests so that you can then compare it to, hopefully, the other hundreds of people that have run the same tests on different kind of hardware. Because there's a lot of myths around what actually affects the performance of a Revit session. Is RAM good? Is video card good? And we just want to debunk a lot of that stuff. So, but it's kind of taking a big data approach to benchmarking hardware for BIM usage or production. And man, this thing's long. I thought I'd get through it faster. So some ideas on things that I'm excited about. Kind of sensors and usage metrics, and not the traditional ways of capturing them, Arduino or Zigbee, all these kind of really interesting technologies out there to monitor the way buildings are being used or run, whether it be the BMS, SIMS, CAFM, sensors, all that kind of stuff. Indoor positioning is something I think is going to change retail as a market completely. My Windows is broken. Lost my cursor. Indoor positioning, I think, is something that's going to be just part of the way that things like retail go together. You walk down a certain aisle, and there's a discount on a particular DVD. Well, DVDs won't exist anymore, but whatever. You'll get, zapped a coupon to your phone, or it's going to tell you to go to different places, or egress. All that kind of stuff is going to be very possible and very accessible.
Those who have never been in.
And this, I don't know what's going to happen with this, but I just think it's interesting that Google is scanning the inside of buildings. I figure if Google collects data, they monetize it, so I'm saying monetizing building data. They're taking the same street view technology and doing it to the inside of buildings. They've got to be doing it for a reason. They can probably start to identify through photogrammetry or different things what kind of products are in buildings or what people are in buildings. But I feel like AE professionals should be at the head of this since they're authoring that data. They've got it in the BIM model, they put that thing there, and now someone's coming in after the fact, scanning it and using it for something. So I think it's just something to be looking out for. And then what I call facility APIs. API, application programming interface, as opposed to a GUI or GUI, a graphical user interface, is a code-based way to access an application. That's oftentimes paired with an SDK, software development kit. And so I can imagine buildings having an API. As a facility manager or an owner organization, I want to access the building API to get the latest room names. And I see an opportunity for AE professionals to kind of curate that data. So I make a call, som.get room names, and it pulls in, and firms might be able to license that data or provide a service in managing and hosting that data. Or when they want to reconfigure their space, that's the first person they call. So there's a lot of, I think, opportunities to use that data and either monetize it or create new business opportunities that BIM presents. I don't know what that would look like. I don't know if that sits on a bigger platform to host all those APIs. That would be my guess, that there's going to be some sort of PayPal of building data. But anyways, just another provocation there. And so yeah, I say data is the raw renewable resource, and those that use it to deliver value will and ultimately drive performance and affect the building industry. So we think buildings equal data, and it's on us to take advantage of it. Thanks. We have 2 minutes for questions or comments. Is there any?
I couldn't be more biased, but I think the X3D is very well suited for that data flow you showed. Question, we've speculated in our community, extensible 3D graphics, about accessibility, physical accessibility for data, for people who, wheelchair access, vision impaired, et cetera, and that should also be part of these building models. Somebody could see, well, how would I get to the second floor of City Hall to get married, or is the restroom accessible? is there any effort to regularize some of that stuff?
Well, there's things happening with model checking for new facilities. So you submit your model and it'll check to make sure that you're complying with all the accessibility code, because a lot of those are very algorithmic tests. You know, is the doorway big enough? Can I get from here to that? There's a cool software called Celebri that's a rule-based model checker, and you can create rules. And it's being used, you know, do the slopes on the ramps meet the right amount? Because a building code reviewer can only catch so much. And so yeah, automation. Chuck Eastman out of Georgia Tech is doing some very interesting research on that, particularly around egress and path to exit and all that kind of stuff, and all through algorithms. It's really cool stuff.
Fiatech's also got the AutoCodes project, which was a former ICC that they've taken over now, and they've actually done it where they have 6 municipalities they worked with in the past year, and they've completely submitted it. This is in the planning stages, and for building permits electronically, they went from 60 days to 60 seconds. And it checks all life safety issues, everything is for the code for that municipality.
Yeah, I think one of the biggest hurdles is going to be getting people processes to accept and embrace these kinds of things. Because I don't think, conjecture on my part, many building departments are going to be too excited about the code review process going down from 60 days to 60 seconds. Hopefully they would use that time gained in a productive way, but people just don't think that way.
Well, actually, we were working on smart permitting here in Silicon Valley between 1995 and 2000. And part of the idea was that the architects and engineers can start to do their own plan check before they submit to the building department. It didn't always necessarily mean that the planning department was automatically going to accept that short duration. They were still going to do a lot of their own checking, but the idea was that you'd be able to work out all your kinks before you submitted to the building department, and also made their jobs quite a bit easier as well.
What happened?
The architects decided that around here that they didn't feel comfortable that it was too much financial risk and legal risk about turning in their documents electronically to the building department. So Singapore came over, saw what we did, and immediately adopted it and implemented it.
Yeah, Singapore is one of the few countries right now that is requiring BIM. The UK has a 2016, sorry.
BIM as it's the national standard of IFC.
Yep, IFC Industry Foundation
not
Class.
BIM in the generic sense.
Right, not BIM as synonymous to Revit, but BIM as, that kind of broader. And in Europe and Singapore, they're standardizing on IFC, which is an open BIM format. So it's some pretty cool stuff. And Celebri's all IFC based.
And if I could just make a quick observation to this group here. You mentioned earlier at the beginning of your presentation, you don't see why buildings aren't adopting more information about sensors and why this does become ubiquitous to become smart city data and all that. My observation after being in this industry for 40 years has been essentially you have to get through a generational change of leadership. And so right now you've got older baby boomers and even people who are older than the baby boomers still at the head of business that have hang-ups about making certain information available to everybody. They don't think they're not comfortable with these information. And essentially what's going to take is a bit of generational shift at the leadership level. That's where all you folks come in. Because that's what I'm so excited about seeing all you folks, the young Gen X and Gen Ys here really work on this stuff. But again, it's going to take a while for this stuff to move into the adoption phase. Plus, we didn't have the tools and technologies that you have today. So it's going to take a while for this stuff to catch on. But this is really an exciting group.
Yeah, it's super cool stuff. I think events like this are going to be where we're going, and it's also going to be. This industry, unfortunately, does not change until it has to. So as you see companies like Facebook procuring buildings and saying, this is the way you have to work, then people will. And I think we're starting to see that as well. Just the pressures on financial performance and facility performance are getting so high that owner organizations, the people building buildings, are putting these kinds of demands on companies. So cool, I think I'll wrap with that. Well, you can grab me, I'll be around for a little bit. Thanks.